Autophagy plays a key supportive role in the metabolic activity of brown and beige fat cells, specialized adipose tissues that help the body burn energy as heat, a process known as thermogenesis. Unlike white fat, which primarily stores energy, brown and beige fat are metabolically active and can protect against weight gain by increasing energy expenditure. The ability of these thermogenic fat cells to maintain high mitochondrial content and rapidly oxidize fatty acids depends on robust autophagic function, particularly during states of cold exposure, calorie deficit, or metabolic stress. In this way, autophagy not only preserves the health of brown and beige fat but also enhances their fat-burning potential, making it an important ally in the body's natural defense against obesity. At a cellular level, brown and beige adipocytes contain an unusually high number of mitochondria, tiny energy factories that generate heat through uncoupled respiration, driven by the protein UCP1, uncoupling protein 1. Autophagy, and specifically mitophagy, the selective removal of damaged mitochondria, ensures that these energy systems stay functional and efficient. Without proper autophagic activity, dysfunctional mitochondria accumulate, impairing the thermogenic ability of these fat cells. This can lead to reduced heat production and a lower resting metabolic rate, which in turn contributes to fat accumulation and increased obesity risk. In both animal and human studies, impaired autophagy in thermogenic fat is associated with diminished cold-induced thermogenesis and weight gain, even when calorie intake is unchanged. Interestingly, autophagy also influences the formation of beige fat, which emerges within white fat depots in response to stimuli like cold, exercise, or certain hormones. This process, known as beiging, involves a dramatic metabolic shift as white adipocytes adopt features of brown fat. Autophagy facilitates this transformation by remodeling intracellular components, clearing out lipid droplets and organelles to make room for new mitochondria and the machinery needed for thermogenesis. Without autophagy, this cellular reprogramming becomes incomplete or defective, leading to a reduced beige fat response and diminished energy expenditure. In this way, autophagy doesn't just support existing thermogenic cells, it helps create more of them under the right environmental or physiological conditions. The connection between autophagy and thermogenic fat is not only a fascinating biological relationship, but a promising therapeutic frontier. Enhancing autophagy in brown and beige fat could help increase whole-body energy expenditure, making it easier to prevent or reverse obesity. Several interventions already known to stimulate autophagy, such as intermittent fasting, cold exposure, and aerobic exercise, also promote brown and beige fat activity, suggesting that their metabolic benefits may be partially linked through shared mechanisms. Likewise, compounds that activate YMPK or inhibit mTOR could theoretically increase thermogenesis by supporting autophagy in these cells, although more research is needed to confirm this pathway in humans. It's also worth noting that this process appears to decline with age and with obesity itself. In obese individuals, autophagic signaling is often suppressed, even in brown fat, leading to lower thermogenic activity and a reduced capacity to burn calories. This forms another metabolic feedback loop where impaired autophagy reduces fat-burning potential, which then contributes to further weight gain and worsens autophagy suppression. However, this state is not permanent. Studies suggest that autophagic capacity in thermogenic fat can be at least partially restored with lifestyle changes, allowing the body to re-engage its innate thermogenic machinery and improve metabolic resilience. In sum, autophagy is essential to the function and formation of brown and beige fat, two of the body's most powerful tools for burning excess energy and defending against obesity. By maintaining mitochondrial health, supporting cellular remodeling, and responding to environmental signals like cold and exercise, autophagy keeps thermogenic adipose tissue active and adaptive. This not only aids in weight regulation but also enhances metabolic flexibility, glucose control, and resistance to age-related decline. Supporting this process through targeted behaviors and emerging therapies could offer a safe and natural means of boosting energy expenditure and restoring balance in individuals struggling with obesity.